All right, here we go. Last chapter of the year, 9-1, quadratic graphs and their properties. Today's learning objective is we're going to understand quadratic functions and their graphs. So we've got some key vocabulary, and our key vocabulary are these right here. And y'all, I don't know what's going on with me. Quarantine's got me like, whoa. So a parabola, it's not a parabola, which I said all through my intermediate algebra. It's a parabola, is a U-shaped curve that is the function of a quadratic function, or the graph of a quadratic function. So a parabola is a graph that makes a U, and it can either be a happy face or a frown face. The quadratic parent function is ax squared plus bx plus c, and you've been factoring those, so you've seen them. They may not have an a, they may not have a c, they may not have a bx, but what you're really looking for here is this piece right there, that ax squared. So that x squared is what's going to tell you that you've got a quadratic formula. The axis of symmetry is where the parabola folds itself in half. And so if you pay any attention to art, like symmetry is that thing where you can like flip something. So does it look the same on one side or the other? The package does, but the word doesn't. Yeah, I'm going to eat those later. The vertex is either the highest point of the parabola or the lowest point of the parabola. And then the minimum is your vertex point if your a value, so back again, if this a value is greater than 0, it's going to be a smiley face. And if it's less than 0, it's going to be a frowny face. So negative quadratic functions are frowny faces, so negative, frowny, right? Positive are the happy faces. And that's going to tell you if it has a minimum or a maximum based off of how the U goes. So if it's a smiley face, the bottom of the U is your vertex, and that vertex is a minimum. If you have a positive, the frowny face, the top of the U is your vertex, so it's your maximum. There are a few other things that when we look at a quadratic formula, there's some more vocabulary. So kind of these are your solutions. So when we say solve a quadratic equation, we're looking for these 2 points that this parabola crosses my x-axis. So the 2 points. Here's my vertex. The y-intercept is exactly what you would think, and even though it has 2 x-intercepts, it only will have 1 y-intercept. Sometimes your vertex is on your y-intercept, not all the time. And then your axis of symmetry is that like invisible line that if I were to fold this smiley face in half, it would line up exactly like it. If you were, for example, to get a if you were to get a line that looked like that, this is not a parabola, so I can't fold this line. This is a terrible line. But I can't fold this and make it look the exact same. So parabolas have to have that. I can never get the eraser to work on this. There we go. Parabolas have to have that like axis of symmetry in order to fold it and make it go exactly in half. Okay. So let's identify the vertex. So remember, the vertex is either that very top point or the very bottom point of that parabola. So we're just looking for that point, and we just have to name the point. It's seriously easy. So here we go. I'm going to do 1, and then you're going to do 2. So what are the coordinates of the vertex? Is it a minimum or a maximum? So I notice right away that this is, heck yeah, I'm going to use a purple one. This is a smiley face, so we've got that positive quadratic equation. And the vertex is this point right there. So I need to name that point, and that point, if I start at 0, that point is I'm going over 1 and down 1. So my vertex is positive 1, negative 1. Go ahead and pause it. Do the other two. They're super hard. Come back and check your work. Pause it now. Okay, welcome back. So on this first one, I went in and found that my vertex is right there. It's a frowny face, so it has a maximum, and that point is at 0, +3. On the second one, I have a smiley face, so my vertex is right here. It's a minimum. It's the smallest, or it's the furthest down that line is going to go, and the point is located at -2, -3. All right, so now what we're going to do is we're going to graph some quadratic equations. Basically, there's 2 steps. You make a table, you plot your points. So remember, we're going to use that special set. And our special set, we want to kind of stick with that -2 to +2 so we can get all of the points right around the origin so we can see exactly where is this parabola going. Remember, exponential functions get wider very quickly. So the more the larger your a value is with that exponent, the wider your parabola is going to be. So we want to stick right around that origin so that we can see as close or as much of that parabola as we can in the window that we're given for the graph. So I've already made a table for you, and we are given our equation up here. I am going to get my calculator. Do not feel as though you cannot use a calculator at this point. You are in a high school accredited math class and you can do that. So basically what this is saying is that our x value is going to be squared, and then whatever that is, it's going to be multiplied by 1/3. So I am going to use these special set. So I'm going to use -2, -1, 0, 1, and 2. If you wanted to use more mental math, you want to pick numbers that are going to be easily divisible by 3. So we could essentially change this to, if I can erase. Why doesn't it ever let me erase? There it goes. Yeah, I don't know what it's doing now. That's weird. Okay, so we could also do like -6, -3, 0, 3, and 6. But I don't want to get this too wide because I'm not going to be able to get my point up here once I square it, because 6 squared is 36 and I don't have 36 points here. So that's why I'm going to stick with those -2s. But if you wanted to use more mental math, that's where you do it. So I'm going to go back in here, -2, -1, 0, 1, and 2. And then I'm just going to literally plug in those x values into, why is this doing this? There it goes. Okay, I'm going to literally plug these x values right into that x. So I'm going to square it. So -2 squared, -2 times -2 is -4 times 1/3, or you can kind of estimate that 0.33333. So I have +4 times 0.3333, and that gets me like 1.1 1/3. That is a terrible fraction. Oh, we're good. Okay, so now I'm going to plug the 1 in here. So 1 squared, -1 squared, -1 times -1 is 1, times 1/3 is 1/3. Okay, 0 squared is 0. We learned this. And then 0 times 1/3 is 0. And then these ones are actually the exact. Sorry, I accidentally paused the video and it stops my other one. So these ones are actually the exact same. And okay, so now we've got points, so we're just going to go in and plot them. Okay, and I am going to make this be in 2/3. So my first point was at -2 and then 1 1/3. So I need to go back 6 because 2 -2 is the same thing as 6/3, -6/3. So I need to go back 6/3 and then I need to go up 4/3 to get to that 1 1/3. So I'm going to go back 1, 2, 3, 4, 5, 6, and then up 4. 1, 2, 3, 4. And then this is going to help me start getting this parabola going. And then we have 1 and then 1/3. So I'm going to go back 3 and then up 1 and then 0, 0. And then it should, if it's a true quadratic equation, you should be able to just kind of mirror it on the other side. So I get this point right here and then this point right here. And then when I connect, and let's see if my iPad actually lets me connect these. There we go, not too bad. I get this nice U shape, and you can tell that this is my minimum, and it makes sense because I had a positive A value, so I have a happy face. So that's my minimum. So, or my vertex. So let's go ahead and kind of fill these out. So my vertex is at, excuse me, 0, 0. And then the domain is any value that you could kind of, you know, if you were walking along this x or this x axis here, how or what is the value or the range that this could be in order to fit on here. And because this line is actually going on and on forever, that's what this arrow means, we actually have a domain of infinity. And it's both positive and negative infinity, so we're going to write positive and negative, because it doesn't matter. I can go to positive 6,743 and go up, and eventually I'm going to land on this parabola at some point. Now the range, on the other hand, is different, because the range has a definite stopping spot, and that stopping spot is this vertex right here. It will not go down. So if I'm walking along this y-axis, I can be anywhere in these positive values, and I can move over in any direction, and I will run into this parabola. But if I were to go to like -4, you know, I'm never going to land on this parabola if I go on my x value at some point. So my range is, do you remember function notation from like unit 3? Well, here it's coming into place. So our range is, we use those brackets and we say 0 to infinity, positive infinity. And we're saying that anywhere from 0 to positive infinity on that y-axis is where this parabola can meet. That's it. So I'd like for you to give this one a shot. Go ahead and pause it, come back and check your work. Okay, not sure why it wouldn't let me put my face on it, but this is your answer. So I have a negative parabola, which makes sense because I have this. So my vertex is at 0, 0. My range, remember we're looking at what values can land on that y-axis. I have negative infinity to positive, well, to 0. And then my domain is plus or minus infinity. So what are some things that you noticed about the graphs on the last 2 pages, and how did their widths compare? Did you notice that this one was really skinny, and as we were kind of going up and then going down, it increased at a pretty exponential rate? That's due to this integer that's right there. The other one, on the other hand, even though we had a much smaller scale, is a really wide parabola. So if I can figure out which button makes things work here. If a is a fraction, it's going to have a slower growth and a wider parabola. If a is an integer, it's a faster growth and a narrower parabola. If a is positive, it has a minimum, and if a is negative, it has a maximum. So what I want us to do is I want us to order these from widest to narrowest. So remember, the smaller the fraction, the wider the parabola. The bigger the integer, the narrower the parabola. So first thing that I notice is I have 2 integers and 1 fraction. So immediately I know that the first one is this one. If I'm going from widest to narrowest, the first one is this one. The second one is going to be this -2, and then the widest is going to be the +4. I'd like for you to pause your video and go ahead and do this one right here. Okay, so I got the equation with the 1/4, the equation with the -2/3, the -3, and then the 5. All right, now we're going to find the axis of symmetry from an equation. So we're going to use this formula, x equals -b over 2a. So we need to remember that when we've got an equation in ax squared plus bx, plus c, what we're looking for is we're looking for this b, and we're going to make it the opposite of it, whatever it happens to be, and then 2 times whatever our a value is. So let's give it a shot. We're just going to use this formula, and we're going to find that axis of symmetry. So I am going to highlight my b, and my b is right here. And remember, I need the opposite of b. And then my a is right here, and I have that invisible 1 that's hanging out right there. So we're going to use this formula. I say x equals -b, or the opposite of what -6 is. So the opposite of -6 is +6. And then 2 times my a value, which is 1. Now I'm just going to go in and simplify. X equals 6 over 2, so x equals 3. That's it. At x equals 3, so on a graph at 1, 2, 3, this is my axis of symmetry. So whatever parabola I have, that's where my fold line is, that I can put it, and then it's the same. So what I'd like for you to do is go ahead and pause it and try these two. Remember, you're still using the same thing, even though this is x's and or h's and t's. You're still using the same formula over here. We just have different letters. So give it a shot, pause it, come back and check your work. All right, I got x is -2. I'm sorry, x is 2, and then x is 3/2. If you didn't get those two answers, make sure you pause it, look over my work, check your work. If you did, let's move on. So basically, the big concept of this lesson is a quadratic function is a type of a non-linear function. So remember, linear means straight line. So non-straight line, that models certain situations where the rate of change is not constant. The graph of a quadratic function is a symmetric curve. It means it can fold in half, with a highest or lowest point corresponding to a maximum or minimum. Don't forget, you have your practice work on Math Excel. And if you have any questions, make sure you come to Zoom, because I sit on it all day long. Hope you have a great day. We'll talk to you later.